This is called the solubility curve. Remember during the notes earlier this week, you had the terms supersaturated. Okay, for some reason this thing's not writing. You had saturated. And you had unsaturated solutions. Okay? Now, and I showed you some test tubes, and you had those on notes on page 43. Okay? Now, looking at this graph, you're going to be able to tell whether it's supersaturated, saturated. Let's move this, make that a little bigger. Or unsaturated. Okay? Now, you're going to look at a chemical. So pick one. Pick anything you want. Pick one of the chemicals here on the graph. K, you mean KClO3? Oh, KNO3? Okay. So that's this line right here, right? Okay. So now, let's say at 60 degrees, here's your 60 degrees, and I ask you how many grams does KNO3 have in this particular curve? You're going to go all the way up here, and yes, your dot would be right there, and that's right on the line, and that gives you 90 grams for every 100 gram sample of water. This is a saturated solution because you can dissolve up to those 90 grams. Think of this whole graph as a beaker, okay? And in this beaker, I can actually put in 90 grams of the KNO3 for every 100 gram sample of water, and you dissolve 90 grams. Now, in a normal state, can I dissolve more than that? No, because that's what it's capable of dissolving. That's a saturated solution, okay? But if I warm up the water, do something to it, and let's say I put a 120 gram sample on a 60 degrees Celsius, did I go above that line of what it's capable of? Yes, I did, right? Okay, so this would be a super saturated solution. Okay, because I dissolved more than what I should be able to dissolve in that particular beaker. Okay? Okay, now let's say I give you something like let's say 20 grams at 80 degrees. Here's 80 degrees. And here's 20 grams of NaCl. So my dot is right here, my little plot. Is that on the line, above the line, or below the line? Below. It's below the line. So it's unsaturated. Okay, very good. Okay. And that's because I still have from here to here, I could put in about how many more grams? If like another 20, right? Because it's on that 40. So if I already have the 20 grams to hit the actual mark for the saturated, I can put in another 20 grams. Okay? And that would make it a saturated solution. If you go over it, it's super saturated. And that's it. That's how you're identifying. Okay, any questions so far?
So 40 or under is unsaturated?
If it depends on where, what chemicals. Like, so for NaCl, if you get 40, that's right on the line, that's a saturated solution. Wherever you're plotting your dot. Okay, let's do another one. Like, NH3. Okay, let's do NH3. If I do 30 grams of NH3, and I do 50 grams. Here's the 50 grams. Okay, let's get out of there. Oh my gosh. Okay, if I get the 50 grams, and here's the NaO3 at 30 degrees, right here, it's a little bit below the line of the NH3, correct? So is that saturated, supersaturated, or unsaturated? It's unsaturated because it's a little bit below the line. Because your line is right there. Okay, now I marked it in so it looks like it's all the same.
On the line, then saturated.
If it's on the line, it's saturated. If it's not, and it's below the line, it's your unsaturated. Okay? If it's above the line, then it's going to be your supersaturated. Okay? Yes? Anyone else unclear? Are we sure?
Like some of these questions are confusing me.
Well, we're still doing other things. So, huh?
How is the K or the NaNO3 supersaturated? If it's under.
The KNO3?
No, the supersaturated. You said just above the saturated.
Right. So when we did KNO3, the dot was up here because we did 120 grams at the 60 degrees, and it was above the KNO3 line. So because that dot was up here, that's why it's super saturated. Okay? Okay, Mihan, like this, look. Okay? Line you have. Let's say this is HCl. Whatever line you have. Whatever, let's say this is 80 degrees, and you're looking at 40 degrees Celsius. You have to do a plot, like a graphing dot, right? Where do they meet? If this dot is above the actual line of the HCl, that's when it's super saturated. Okay? Now, if the dot was over here and it was right on the line of the HCl, then that would be saturated. Okay? Now, if I did something else and I plotted my dot at 40 degrees, and you see how HCl is still up here? This is my line for HCl. You're looking at the dot compared to where the line of your chemical is. If this dot is below the line, then it's unsaturated. Okay, my stylus is not writing correctly. Okay, but you see that? Yes? Okay, very good. Anyone else, bless you, have a question on that before we go on? We sure? Okay. All right, so let's go back to the graph. You know what? Let's just do a next page. And let's do the graph again. Okay. Okay, so now let's look at the graph. Okay, and let's do a separate question. Think of each graph as a beaker, and you have only 100 grams of water for every beaker, okay? Let's say I say, how many grams do you have of NH3 at 60 degrees Celsius per this 100 gram sample? So here's my 60 degrees Celsius. Here's my NH3, correct? So how many grams do I have? Like 18, 19, right? So I have 18 grams for every 100 gram sample. That's it. You see how this dot is right here? So you're going to look over here to see how many grams you have. Okay? Because that's where you put your dot. Now, what if I said, how many grams of this same NH3 at 60 degrees still, at 60 degrees Celsius, but in a 300 gram sample
Wouldn't it be
of
18
water?
times 3?
So 18 times 3 gives you the total grams of the NH3. Okay, we see that? Okay, now look at the graph itself. Most of your lines are going where? They're going up or down? They're going up, right? So the higher the temperature, the more solubility you have, and those are your solids, okay, that are being dissolved in water. Which ones are not doing the same thing? Which ones are not going up?
What? Which ones are not going up?
Yeah.
KCl and
KCl is going up. NH3 is the one that's kind of going down, right? So the hotter the temperature, the less you're able to dissolve, correctly? Right? Okay, so what does that mean? Is this a solid? What dissolves more at cooler temperature? Remember the notes from Monday? What dissolves more at a cooler temperature?
The gas.
The gas. So that tells you that this is a gas because you have less solubility over here at the higher temperatures. Okay? You can also look at this graph and then be able to say, well, let's say at 30 degrees, what dissolved the least at 30 degrees Celsius? The KClO3, because it's right there. And this dissolved only about 10 grams. Very good. Okay, so now take those same 30 grams. Which one dissolved the most in this graph? The NaNO3, because it's all the way up here. Very good. But you see how you look at the 30 degrees Celsius? So your question's going to tell you where to look. Is it at 40 degrees, at 60 degrees, 80 degrees? Okay. And it's going to also tell you, is it in just this 100 gram sample, or is it going to be at 300 grams or 400 grams? All you have to do is figure out what it is here and then multiply by whatever you're looking for. Correct? Yes? Okay, where do we have questions so far? I know this was kind of quick. Where do we have questions so far? Are we sure? Are we positive?
Finding out the solubility.
Finding out the solubility?
Like 50 Celsius.
Right, and what you're going to do there is you're going to look at just like, okay, right now you just said 50 degrees. So here's 50 degrees. And if it's the least amount that's soluble, that means at the bottom, because this is your least amount of grams, right? So let's say here, this would be the KClO3 that dissolves the least out of all of these chemicals. If you're looking at the same 50 degrees and you want to know the most, you go all the way to the top one and see which one dissolved the most at that particular line. Okay? You see that? And so then the NaNO3 would have dissolved the most. Because you see how the side is telling you how many grams you're dissolving? Right here on the side. Yes? Okay, I'll be right there if you need more help. All right? Okay, any other questions? We sure? Okay, one more thing. This class got the highest average for the benchmark.